This episode contains graphic descriptions of crime scenes which may be disturbing to some listeners.
Back in the 1970s and 80s, one man terrorized residents of California in a multi-county 13-year crime spree. His atrocities included murder, attempted murder, kidnapping, rape, robbery, and burglary. He inflicted untold suffering upon hundreds, if not thousands, of innocent victims. For years, he eluded law enforcement, but it was the way he was ultimately identified that changed the way we look at DNA as a crime-fighting tool. Welcome to APB Cold Case Spotlight DNA.
This is APB Cold Case. Here's your host, former police chief Mark Spahn.
Our story begins in the cool early morning hours of March 13, 1980, in a modest home on High Point Drive, overlooking the city of Ventura and the Pacific Ocean in California. 28-year-old Charlene Smith and her 38-year-old husband Lyman were asleep in bed when an intruder entered their home. According to a report in the Quester files, the couple awoke to find a man in their bedroom. The intruder directed Charlene to bind her husband's wrists behind his back. The intruder then bound Charlene's wrists and Lyman's ankles. He forced a terrified Charlene into another bedroom and savagely raped her. Then he took her back to the master bedroom where he bludgeoned the defenseless couple to death. Their brutalized bodies were found 3 days later by Lyman's 12-year-old son. At the time, police questioned whether this could be the work of the East Area rapist. Detectives looked at several potential persons of interest early on in the investigation, but eventually the case went cold. Fast forward almost 4 decades to April 24, 2018. Authorities arrest 72-year-old Joseph James D'Angelo at his home in Northern California. D'Angelo would have been 34 at the time of the Smith murders.
And everybody in California for the past 40 years had been trying to catch that guy with DNA. We knew him as the East Area rapist, Visalia ransacker, the Diamond Knot killer, and now he's known as the Golden State Killer. And finally he's arrested, and I'm like, well, let me call my friends and find out who did it, how they found him, who arrested him. Nobody knew anything. It was crickets. And I thought, this is the weirdest thing that none of my DNA analyst friends knew anything about the arrest of Joseph James D'Angelo. The forensics world was dark. And so after he was arraigned at court, I was able to reach out to some contacts at this Sacramento County DA's office. And I said, what is going on? And they said it was genetic genealogy. And 5 of us got together, and it took us 63 days to find him. And I was like, okay, this is a game changer.
That was Toby Kirschman, who got her start in forensics and DNA at the California State Laboratory, one of the largest DNA labs in the world. Toby had moved to New York right around the time her former colleagues in California were connecting the dots in a string of vicious crimes committed by the man known as the East Area Rapist, the Visalia ransacker, the Diamond Knot Killer, and the Golden State Killer, names now associated with D'Angelo before his identity was known, and who was connected to the Lyman and Charlene Smith murders we just spoke about. DNA became a game changer in crime scene forensics in the 80s, and since that time, the science surrounding DNA has continued to evolve. In the early years of DNA, good quality samples were needed in order to make an ID. But advances in technology can now provide DNA profiles on smaller, older, degraded samples. We'll talk more with Toby about that, but let's take a deeper dive into some of the terminology that you may have heard in the media and in some of our previous episodes involving DNA. One of those terms is sequencing.
So sequencing is the analysis of a DNA sample, so DNA evidence. There's 2 kinds of sequencing. The fast, easy kind is SNP or SNP analysis. And in that type of analysis, single nucleotide polymorphisms are determined. And it's just kind of a quick and dirty way of pulling out who someone is compared to another person. So in other words, you don't look at the entire genome. You look at these more specific markers, which is good enough, right? Because there's thousands of them. But You and I, we would just, with our fresh, wonderful cells, we could get a SNP profile done, and they're really quick and easy, relatively speaking.
The other technology can help law enforcement in identifying those older, degraded biological samples.
The second kind of sequencing that exists for forensic evidence is whole genome sequencing. And that's when you sequence the entire genome, right? And so you need a larger machine, and it's a slower process. So sequencing is done for highly degraded DNA, old DNA samples, like a bone that's been out in the desert for 200 years. That's definitely going to need whole genome sequencing.
Toby told me that most crime labs today are still using the same type analysis they used in the 90s.
And that was when we first kind of had CODIS, and we had short tandem repeat analysis, STR analysis, got all the states together, formed the crime laboratories, and created this one database where everybody could dump their DNA samples and we could compare them county to county, city to county, state to state, etc. Right? So that was in the 90s. I still think that every crime lab in America is only doing STR typing from 1994.
So there's a couple terms I wanted to know more about. STR, short tandem repeat, and SNP, single nucleotide polymorphism.
So here's what I want people to remember. If you hear STR, think of old. And when you hear SNP, think of new. So the STR represents the kind of classic CODIS DNA profile. Say, for example, if you found some blood at a crime scene and you say, oh, this is the perpetrator's blood, and the year is 1999, you would send that DNA to the crime lab where they would process an STR profile. And so what they would do is they would identify the allele call from your mom and from your dad at 13 different locations on your DNA. And that the number from your mom and the number from your dad would get uploaded to CODIS. And that analysis is called short tandem repeat. And I can totally go into, explaining that, but it's old. And so, it's old / it is still currently the way that all laboratories are doing it, but every single lab is scrambling and figuring out how to apply for grants and how to get a sequencer in-house so that they can do the new SNP analysis.
So if most government crime labs are only doing STR analysis, how can police access the newer, better SNP sequencing? Turns out it's mostly private labs and university labs that have the high-end sequencers for this emerging technology.
So we're actually seeing a pathway form.
And once an investigator gets their DNA sample sequenced, they'd run it through CODIS, the National DNA Database. CODIS stands for the Combined DNA Index System, a database administered by the FBI similar to their national fingerprint files. And if the investigator doesn't get a match that way, they can take that sequence and compare it to open source DNA databases like GEDmatch, Family Tree DNA, and DNA Justice, places where the general public can upload their own DNA profile to search and compare their ancestry. So today we have amateur and professional genealogists using DNA to help build family trees and locate relatives. And this is where we get one of the newer terms, investigative genetic genealogy, or forensic genetic genealogy. You can look at it as a marriage between DNA science and old school genealogy. A DNA profile from a crime scene can also be compared to these open source systems. And if they find a possible match, that's where a forensic genealogist comes in, to connect the dots and build that family tree. So how does it work? According to an article by Claire Glenn published on the National Institute of Health website, the unknown or crime scene sample is uploaded and compared against user profiles, looking for those that share some DNA in common, something to show that they're genetically connected. Those relatives could be close, like a parent, child, or sibling, Or they might indicate a more distant relationship, like a cousin. The article goes on to say that the amount of DNA shared is used to determine possible DNA matches. The more DNA in common, the closer the relationship. Then, by using other evidence like public records, the genealogist starts to build a family tree. Their goal is to find the most recent common ancestor, or MRCA. This process can result in narrowing down the match to close family members, or maybe an identification to the actual person. I asked Toby Kirschman where investigative genetic genealogy would be without these independent open-source DNA databases.
Mark, that is such a good question. I'm so glad that you asked it. We're nowhere. We are nowhere without those databases. There are three. There's GEDmatch, FTDNA, and DNA Justice.
Toby told me a heartbreaking story about a woman who'd been trafficked, and she was trying to find out who the father of her son was.
Ages ago, before I really understood what genetic genealogy could do, this woman reached out to me and said, I was trafficked for a little while, and I believe that my son might be the result of an encounter with my father. And she said, is there anything that you can do to help me? And at that point, I said, I don't think so. Your best bet would be to go to your local law enforcement agent and try to go the STR route. I wouldn't have to say that today, now that I've thought through it. The woman, and she has a right to know about the biology that was involved with her children. If she has a question, if the children have a question, and this boy was 20, right? If they both tested at, for example, ancestry.com and then uploaded, to their database, they could contact somebody like me and I could tell them their paternal line. I could say, yes, that is something that we can answer today. And so it's really interesting that some of these questions are now answerable because of other people participating in this big database. And it goes beyond the purview of the law enforcement. New territory.
So, as we've heard, the ability to find a family relationship through DNA requires a robust database. I asked Toby about the process of uploading your own DNA to one of these databases and how a user's notified about connections to other users.
So there are a few decision-making levels that you have to go through when you do your DNA. The first one I must mention is that every company has a different set of terms of service. It's really important, if you're going to put your DNA out there, that you have a fair understanding of what the company is saying they will do or will not do. And you contain all of the control insofar as it is controllable. But if in these terms of service, they'll ask you, they'll prompt you, they'll say, okay, great, thanks for doing your DNA test with us. Would you like to learn about people that share DNA with you? Yes or no?
And just like DNA science, the technology and business of open source DNA databases is emerging as well. Toby cautions that any user should carefully read the fine print for any of these databases.
And so they really are good. Each company is slightly different, but they'll walk you through these questions to allow you as much privacy as you want versus, whether you want to be seeking these connections. So that's number one. Number two that you have to be aware of is, just like with any data breach, we have no idea what is going to happen with our data when we put it in there. Whether it's, banking or a credit card or DNA, these companies are buying and selling each other. I think it was MyHeritage that changed hands a few years ago, and they went from being headquartered in Israel to, somewhere else. And so this is fair game for the market. So I tell people when I'm teaching this topic, I say, if you have a super private gut reaction, do not put your DNA in the database. If you don't have to.
But with the number of people who have already contributed DNA to these open source websites, Toby says there's already a substantial index of DNA profiles available for comparison. And in the area of ancestry, the combination of DNA science and those open source databases are able to show a connection even to a distant cousin.
So if you find a cousin, if you find a second cousin, that's sweet. You're going to solve that case usually within days. There are a few caveats, but even a third cousin nowadays, you're going to find a distant cousin and you're going to solve that case, probably.
So, we've talked about what can be done to connect the dots for families doing genealogy research, but what about cold cases and law enforcement? In the training programs that Professor Toby Kirschman teaches, she asks her students to imagine a police evidence storage room with boxes of years-old crime scene evidence.
And like, say if you have a cold case, evidence locker, it's all these boxes, right? Say everything is lined up and they all have red lights, meaning that it's a cold case. It's gone no further. As soon as we had the possibility in 2018 to identify perpetrators with DNA, with genetic genealogy, that same evidence locker, all of those red lights would go green. And how many law enforcement agencies are doing a once over with a set of 20/20 goggles on? There's a lot of DNA. And now you can have less with sequencing than you needed for STRs. So with the new sequencing method, you can even have like really small amounts. So it's like a double whammy as far as wins go. If you find a pencil, if you find a shoelace, a cigarette butt, if there was a piece of paper, a newspaper, any of that stuff that was evidence from an unsolved 1960s homicide, that's up. That's a green light.
With the 2018 identification of the Golden State Killer, the world of DNA changed again with investigative genetic genealogy. For detectives, this is a new frontier that might be difficult to navigate, especially for your first case. And the sequencing's expensive. But Toby's nonprofit corporation, DNA Finders, and others like it, are there to help start that conversation.
The most important thing is to reach out about your case. Call me, and all you have to do is start a conversation, no matter who you are, no matter where you are. We will find you the rules and the regulations that your agency will need to make sure that everything that they do is transparent and legal. And we will help you identify the sample, have an interview with and choose a company to process the DNA. We're here to fund everything. We can do fundraising. So there's lots of agencies doing what I'm doing with DNA Finders. It's just to start the conversation and go with it.
Today, the sequencing that agencies would need to process a sample are private, third-party, non-government labs. DNA Finders can help agencies in getting their testing funded.
Well, because we've just become a nonprofit, we're hoping to be able to apply for federal grant. And until then, we are experimenting things like we put a donation button on our page, and then just like doing, local fundraising, maybe holding an event. So we're really, kind of looking into that right now. There's also a season of justice, which is awesome. Any investigator can apply for that. And I have a 100% track record with getting the grants. They just haven't seen them say no. And they'll help fund that sequencing process, which is expensive.
Season of Justice was founded by fellow true crime podcaster Ashley Flowers. For municipalities struggling with limited budgets, this funding can be a turning point in a cold case. The cost today of DNA sequencing might seem overwhelming, especially to smaller agencies or those with several cases, but Toby argues it can actually result in cost savings.
It's not as expensive as keeping a case cold. One time I asked the Cold Case Foundation, in their estimate, how much does it cost to keep a cold case cold, or just, how much does it cost these cold cases to have them? And they estimated about, I think it was $20,000 every time it's open, which would be, maybe every 2 or 3 or 5 years. You could pay maybe $5,000 to close it, or you can keep it open.
I asked Toby about any odd cases that have come across her desk. She told me the story of a man who was adopted, wanting to know if his parents were alive and if he had any brothers or sisters.
And so we performed genetic genealogy on him, and it turned out that we found 6 other living half-siblings that were asking the same question. And some of them knew their mom, but some of them were 100% adopted, and they had all put their DNA into Ancestry. And so when we started looking into these other cases, they also pointed to the same man. And it was a taxi cab driver who was born in 1899, and he lived his life. He had one wife and one or two children, and that's it, as far as we could tell. But we knew because of the DNA that there were at least 6 children that he fathered. And so it got us thinking, what was he doing? We looked into it a little bit, but it was nefarious. Now, there was something going on, right? We were thinking of things like, well, maybe this was a ring. Are we looking at sex trafficking in the early 1900s, 1920s? And he was actually active, like the births that we confirmed had a 30-year gap. So his first illegitimate child 30 years later was the last of those 6 children. So he'd been doing this, for a really long time. And it just brings up the question, we're going to be probably able to find a lot more serial rapists, a lot of really interesting situations. And the question is, if the DNA is out and running around, maybe there shouldn't be a statute of limitations on a case. I don't know. It just brings up a lot of really interesting questions for law enforcement to think about.
So, what does it mean when all of this DNA sequencing and forensic genealogy points to a specific person or a specific family tree? Just because that unknown DNA sample gets identified doesn't mean that it's a suspect.
Yeah, that's like a case that I'm working on right now for a 1994 homicide. There was a beer bottle that was found among a couple that night that doesn't match him. And so all we can do is do the genetic genealogy and then tell the law enforcement agency whose DNA was on the beer bottle. And maybe it is a suspect, or maybe it makes perfect sense and it's not. That's one of the limitations about genetic genealogy. We're going to tell you who that blood spot, who that DNA sample came from, and that may make a lot of sense to the case, or it may not.
I shared with Toby my background in fingerprint identification. And similar to what she described, whether it's a DNA match or a fingerprint match from a crime scene, it doesn't necessarily mean that's your suspect. It just means that a specific person had physical contact with an item. Then it's up to detectives to explore the context of that match in order to determine if it implies guilt or if there's a reasonable, rational explanation for the match.
Now that you mentioned fingerprints, I feel like DNA owes a bit of thanks to the groundwork that fingerprinting laid, because when it first got started in the 90s, the push in court was, look how similar it is to fingerprinting. It's not an invasion of privacy, right? But every single time DNA has gone to the stand, it has won and it has nodded to fingerprinting. It's very, very similar in that it's like you're not taking someone's identity. You're not going to foil them. If you put your thing on something, I'm going to tell the investigator that you left some stuff there, right? And then you guys are going to have to talk with that. But so I really do appreciate the groundwork that fingerprinting laid. It's very, very important for paving the way for DNA.
When it comes to unsolved missing persons cases, Toby and I discussed how investigative genetic genealogy can help detectives in their search.
So with missing people, DNA Finders makes sure that you've done all the DNA that you can. Of course, we make sure that it's circulated in the missing persons and remains indexes. But we do the sequencing too. We make sure that the family of the missing person is not only in, the regular databases like Ancestry and 23andMe, but also in the law enforcement ones. And as soon as those remains pop up, this tree will come to fruition, and that'll be solved.
The cases that are out there where this new technology could help to make an identification and connect remains to a family and maybe provide a new lead to police, well, there's thousands of them.
So let me just throw this out as an example. If you go to the NamUs website for missing and unidentified, New York State has almost 1,500 remains to identify. And those are going to be mostly the whole genome sequencing.
NamUs is the National Missing and Unidentified Persons System, a clearinghouse for all missing, unidentified, and unclaimed persons in the United States. So this next evolution in DNA science, the world of investigative genetic genealogy, is now changing the way we in law enforcement are identifying people, whether they're unidentified deceased, missing, or criminal suspects. Everything changed just a few short years ago when Joseph DeAngelo was identified as the infamous Golden State Killer.
But it was absolutely the pivotal law enforcement case that moved DNA and forensics into the future. It launched it. And we've all been scrambling since. And that was 2018. And so all of a sudden, we have this new ability to solve any case of human identification, no matter whether it's 60 years old or 2 months old. It's just this new thing that we can do, right? And it's just thrown law enforcement and crime labs into chaos ever since then. I feel like we're in the overwhelming stage right now where just from, learning the different agencies and investigators there, it's really difficult for them to be like, do what? They're so used to protecting the privacy and confidential. And when you do genetic genealogy, you kind of have to open up the team a little bit. You have to hire a private company. I mean, some people aren't very comfortable with that. And then you have to hire a genetic genealogist or, talk to a company like mine. And so we're still in the are you kidding me phase, I think.
APB Cold Case has had a front row seat to the use of DNA science and the impact it's had in some of the cases we've covered. I want to share a couple of those with you, just to show how forensic genetic genealogy helps to bring answers. We have one case that's most likely a murder, and another about a man who died from an unknown cause. But the path that these detectives took to get their answers is enlightening, and it truly helps us to understand the power of genetics and DNA. You might remember our story called The Girl in the Well, about a Jane Doe found in Bensalem, Pennsylvania in 1988, and how cold case detective Chris McMullen chased down several leads, including the case of a girl who went missing 5 years earlier in 1983. Detective McMullen methodically collected DNA reference samples from family members of the girl, but there was no match. Frustrated but not giving up, he looked at other missing girls. One of them, 22-year-old Jeanette Tamby, who also disappeared from Bensalem in the mid-'80s. He located her brother Joe Tamby, who provided a DNA swab, and McMullen sent it to the lab.
A couple months go by. I remember I got to work, and there was a letter on my desk from the Center for Human Identification. And literally, as I'm opening the letter, my phone rings. It was them. And they called me and said, we got a mitochondrial hit on your family reference DNA sample for Joseph Tamby. And I'm like, that's it. That's Jane Doe. I know who she is.
But then his moment of excitement turned to surprise. There was a match, but not to the girl in the well.
And they're like, yeah, she's a Jane Doe that was found in Buena Township, New Jersey in August of 1986. And I'm like, what?
A determined Detective McMullen forged ahead. By 2012, there'd been enough advances in DNA technology for a lab to develop a partial genetic DNA profile on his Jane Doe. In 2019, 1 year after the pivotal case of the Golden State Killer that opened the door to this new genetic genealogy, that profile was uploaded to GEDmatch. But unfortunately, that sample was found to be insufficient to develop a family tree. But that would only be a temporary setback.
And then I teamed up with a woman named Yolanda McClary. She's a genealogist. Once we got Jane Doe's profile uploaded and Yolanda actually started working and building the family tree, I could not keep up with her.
Amazingly, a female relative of the girl in the well is identified. An excited Detective McMullen called the first cousin, whom McClary had found in the Pocono area of Pennsylvania. He told me it was a very strange phone call. After all, you're asking someone about a possible relative who's suspected of being missing or dead.
And I told her the whole thing, and she was excited about it, and she wanted to help me. And she said, I was adopted. She said, I don't know much about my biological family. So I as much as she wanted to help me, she didn't have the knowledge. So you run into, curves, twists and turns like that. But anyway.
But then a few days later, Detective McMullen gets a text message from Yolanda McClary telling him to check your email.
Check my email. And she sent me two names, Linda Todd and Joseph Todd. who both lived in Philadelphia. And she said, your Jane Doe is their sister. And I'm like, wow, that's a pretty powerful statement.
You'll remember that Toby Kirschman told us these genetic hits can be close relatives or even distant relatives. This was close. Detective McMullen found a phone number for the daughter of that brother. He left a message.
She called me back. So again, I told her who I was and I explained the situation. And I said, did your father ever have, I didn't even say sister, I just said ever have a sibling that vanished? And she paused for a second and she said, she wasn't even born when this happened, but she said, yeah, he did. She said he had a sister that disappeared. She said around 1985. And I said, what was her name? And she said, Lisa. So literally, I'm just like, that's her. Her name is Lisa. I'm literally looking at her skull on my desk. I'm like, Lisa Todd. I said, where's Dad at? She said, he's on his way home from work. I said, I need to speak with your father. Can you give him my name and number? 20 minutes later, Joseph calls me. And he was just beside himself in a world of emotion. He said, you found my sister? I said, I believe we did. So I asked him for his address. I said, can we come down and talk with you?
And that's the power of this new offshoot of DNA science called investigative genetic genealogy, and its ability not only to put pieces of a puzzle together, but in some cases, to actually go out and find those missing pieces. In the case of Lisa Todd, it took several years, an intrepid detective, and the evolution of forensic techniques to get answers, first to who she was, which then allowed police to focus on how she came to be in that well and how she died.
And I have a very good theory as to who killed her. I think placed her there and hid her there because they were aware of that location. And like I said, she didn't fall. And if she was deceased when she was brought there, she wasn't just dropped down that hole. She was placed there. He knows he's a suspect. I'll tell you that. That's all I'll say at this point.
Another case I want to share began in January 1981 in upstate New York when a body is found in a field. It's a man without any identification, and he doesn't match up with any missing persons reports. It'll turn out that he was never reported missing. Now, there's a number of twists and turns to this story, and you can hear all those details in our episode, Dead Man's Cove. But when it came to getting an ID on this John Doe, Commander Adam Hornick of the Bethlehem, New York PD was on the case. Just like the Pennsylvania investigation of the girl in the well, these happened just before or in the early days of forensic DNA. In fact, CODIS didn't even exist until 1998, 17 years after this case. Commander Hornick located the jaw bones that had been preserved for John Doe and sent them to the University of Texas lab, where a partial DNA string was identified. He encounters some regulatory obstacles about using genetic DNA, so he enlists the help of the FBI, and they also examine the bones that had been in storage for 41 years. They confirm a DNA profile and start building a family tree.
I got a call from Special Agent Giordano of the FBI, and she said, we have our first lead. We did the charts, we're at fourth cousins, we're moving the tree up, we have a lead. And of those branches of the tree, we have found a family member who is in their 80s that's still alive. Everybody else in our charts right now is deceased. They're out in Massachusetts. The FBI was willing to send agents out to this location just outside Boston and interview a lady in her late 80s. And basically the purpose of that interview is, that strange knock on the door of, hey, we're the U.S. government and we're following up on this DNA hit. And somehow you're related to the person, but we don't know exactly how yet because, we weren't able to get that exact kinship ratio of what the relation was. We just knew they were a close relation. That lady in her 80s, that was the first time we ever heard the name of what would later become confirmed as our John Doe. She said, well, this sounds like my nephew, Franklin Feldman. Nobody in our family's seen him in 50 years. And that fit everything.
No one in Franklin Feldman's family had seen him since the 70s. The cause of his death is undetermined, but family members now know some of his story and where he's buried. This was an important case in New York State because it brought attention to the use of family DNA in investigations and resulted in some regulatory changes.
The DNA got us there, the lady spontaneously saying it, and then it was just waiting for those samples to come back. One the FBI did, and the other the New York State Police lab did. So we had them done at 2 separate labs, and the labs basically returned that this kinship ratio of this individual to your John Doe would be this. And in the one case, it was an aunt, and the other was a first cousin, and it matched exactly what our family tree was. It was really those 2 DNA swabs was our confirmation.
Now, we've told you these stories in just a matter of minutes. The actual process can take a long time. But, says Toby Kirschman, it's the pathway to getting an answer.
Now is the time. It takes about a year to 18 months to solve one of these crimes once you start the DNA work. And there are thousands of cases. And I just want to, reiterate to the investigator that it all begins with a phone call. They've got to just be like, okay, I don't want to do it. I don't have the time, but I'm going to start something. And then it'll happen. Magic will happen from there.
Genetic genealogy has arrived. More labs are getting updated technology. We're getting more forensic genealogists to interpret this information. Open source ancestry databases are getting populated with even more family DNA. All of this is helping people find family connections, but it's also helping law enforcement in identifying human remains and in solving crimes.
This is a big, messy, but brilliant way to approach closing and clearing cases. And it's not going anywhere. So it's here to stay.
The messy part of what Toby's referring to is the existing and developing laws, regulations, and procedures surrounding genetic genealogy. And there's also the matter of training a new generation of genetic genealogists.
There's a certification board for genetic genealogy now, just because we can see how big this is going to be. And so we're doing it all. We're like addressing all of the high end, anything that we can think of to make our profession more legitimate, right? So we are here for law enforcement when they're ready.
In the 1980s, labs required substantial samples in order to provide an identification. As the science and technology have continued to evolve, we can now get identifications from old evidence, degraded specimens, or from a single drop of blood or invisible skin cells. There's no telling where the science will take us next. Maybe a world with fewer cold cases, or families no longer waiting decades for answers. Thanks for listening to this special Spotlight episode of APB Cold Case. You can find links to DNA finders and other information in our show notes at apbcoldcase.com.
Thanks for listening to APB Cold Case. Tell us about your cold case at apbcoldcase@spawngroup.com.